This episode was developed out of necessity. Curves like these might seem okay to some, but what if there was a better way to do this in lesser time? There are 3 simple rules to make this trick work. Firstly, 5 points for a complete sine or cosine curve. Secondly, the art of always looking in between. And lastly, a quarter curve at a time. I'll show you how to apply these skills starting with the sine curve. A complete sine curve lies between 0 and 360 degrees. I mark out my endpoints on the x-axis as so. In between 0 and 360 degrees is 180 degrees, so I mark another point there. In between 0 and 180 is 90. I mark a maximum value of 1. And between 180 and 360 is 270 degrees. I mark a minimum value of -1. Now I start to sketch, but only a quarter at a time, focusing on connecting 2 points only. I end up with a respectable looking sine curve with uniform curvatures and evenly distributed maximum and minimum values. Now for the cosine curve. Endpoints of y equals to 1 at 0 and 360 degrees. In between that is 180 degrees, where the minimum value is -1. In between again at 90 degrees on the x-axis, and in between at 270 degrees on the x-axis. Look at that terrible V-shaped curve. Definitely not a cosine curve. It happens when an attempt is made to connect the dots at one shot. But if you remember to construct a quarter curve at a time, such things don't happen. Lastly, the tangent curve. Don't forget to start with 2 asymptotes at 90 and 270 degrees, where tangent values cannot exist. By drawing one curve at a time, tapering off when approaching the asymptote, regular curves can be formed. Okay, that wasn't too hard. What about using this skill set for transformations of trigo curves? There are only 4 types of curve transformations which I've talked about in one of my previous episodes. Website link is provided here. In the context of trigo curves, we start off with the vertical stretch, as seen in this example of 2 sine x. I mark 5 points again, 3 zero values at 0, 360 and 180 degrees. But the in-between points are at 2 and -2 this time. Continue to apply the skill of sketching 1/4 of a curve at a time for a decent looking attempt like this. Now, look at these attempts made without the 5 markers. See the difference in quality? The curves are either too flat and wide or too pointy looking. For a vertical shift, this is really easy to do it fast and right. Simply shift all 5 markers by the same magnitude, keeping the spacing in between the same. Connect the dots one curve at a time for the finished product. Now, contrast this sketch with an incorrect attempt. Look at how the start and end points don't match, which is a common error without any pre-planning. A trigo curve squeeze can also be replicated rapidly. All you need to do is to generate the 5 points repeatedly for the desired number of complete curves. Connect the dots using the same technique, and you'll avoid poorly sketched attempts like what I'm showing you next. Look at how the curves are crammed in haphazardly with an assortment of flat tops and straight lines due to poor spacing. We are almost reaching the end. This final transformation is a shift in the horizontal direction. What you do with your 5 points is to transplant them by the phase shift required and flesh out the necessary portions within the domains. It's all about pattern seeking, so any missing portions can be achieved by generating the sequence. Isn't it more satisfying than a crummy looking attempt like this? To summarize, the 5 points serve as effective place markers for trigo curves due to their cyclical nature. By drawing a quarter curve at a time, there's a higher chance of nailing it on the first attempt, which is more time-saving compared to repeated attempts of tracing the whole curve at one go. The systematic method to generate maximum accuracy in minimal time, so why not give it a go to decide if it works for you?